uh, how this equation is transformed into the equation which is called P is equal to gamma H, let me tell you. Uh, we derived the expression for variation of pressure in z-axis. Now, I wanted to tell you that this negative sign indicates that the pressure is decreasing on increasing y-axis, on increasing distance from in y-axis. So we derive this expression. Let me write it. It was change in pressure per unit change in distance in z-axis is equal to minus gamma. Okay. Now, for an example, mm, if you want, if this is the container, some container, and fluid is contained in it, okay, and there are 2 points in it. One is at the surface and other is here. So this point is 1 and this point is 2. And these 2 points are h distance apart. Okay. So if I asked you to determine pressure at point 2, so you are required to find out pressure at point 2 if you know this equation. So how would you get pressure at 2 using this equation? You first need to you first need to draw one datum line, okay, and the 2 points, the distances of the datum from the 2 points should be specified. That would be, it is Z2, and for this point it is Z1. And from this figure you can see that Z1 minus Z2 is equal to H. Okay. So now we have to use this equation to find out pressure at point 2. So this equation can be written like this: P2 minus P1 over Z2 minus Z1 is equal to minus gamma. So further, P2 is to estimate, and P1, what about P1? The point 1 is exposed to atmosphere, and we say that gauge pressure on the free surface is 0. So what is gauge pressure? Uh, as the name implies, the pressure which is measured by any gauge is called gauge pressure. So gauge pressure, and one pressure is called atmospheric pressure. So the atmospheric pressure is the pressure applied by the atmosphere. So while uh, the gauges give you the pressure which is independent of which does not include uh, atmospheric pressure. So at point 1 we say that gauge pressure is 0, and we are considering gauge pressure at the 2 points. Though you can consider absolute pressure here. I'll be telling you about the definitions of gauge, absolute and atmospheric pressure in a short while. But for instance, on the free surface, just keep that in mind. On a free surface, we are considering pressure as 0. Okay? So P1 here is 0. P1 is 0. So P2 minus 0 over minus Z1 minus Z1 is equal to minus gamma. how you use the equation, but the basis of this equation is this law, the change in pressure per unit elevation. Okay, so pressure with respect to z axis. Then there is which is applied to the stationary fluid, and that law is called law of hydrostatic. Law of hydrostatic. Now, what is this law? It is. Let me tell you. It according to this law, the sum of pressure head and elevation head is constant in stationary fluid. So again, I'm drawing a container. Fluid is contained in it. And there are 2 points inside it where that would be used for the expression of law of hydrostatics. Okay, 2 points. One is here and the other is here. Okay, point 1 and this is point 2. Let me draw the datum also. So similarly, what about this picture? Say there's H2 and H1. So H2, according to the previous law, H2 is equal to P2 over gamma, okay? And H1 is equal to P1 over gamma, isn't it? So this is the same law we just have applied. So, and this is actually called as the pressure head. The depth of the point from the free surface is actually depicting the pressure head. Okay, pressure head at that point. And this Z1 and Z2 are the elevation head. So according to law of hydrostatic, and you can see this in the figure, that Z1 plus H1 is equal to Z2 plus H2. Z1 is the elevation head at point 1, H1 is the pressure head at point 1. So sum of elevation head and pressure head is constant according to this law. Okay, so this is law of hydrostatic applied to static fluid. Okay, so after this discuss about atmospheric pressure. What is atmospheric pressure? It is defined as the weight of air per unit surface area of the earth. It decreases with increase in elevation with respect to the surface of the earth. Standard atmospheric pressure at mean sea level is as flashed. Okay, so it means that when the elevation is greater, elevation with respect to the surface of the earth is greater, what about the pressure there? Atmospheric pressure increases or decreases? Okay, just imagine that there is some thickness of atmosphere over the surface. So when say this is the total thickness of atmosphere, for example. So when you go above this above the surface of the Earth, the thickness of the atmosphere above that point under consideration is lesser, keep on decreasing. When you as you move up from the surface, it will keep on decreasing. So this atmospheric layer thickness will keep on decreasing, and since the thickness is decreasing, so per unit area force or weight is also decreasing. Okay, since the thickness of the atmospheric layer above the point would be decreased, so the per unit weight per unit weight per unit area would be lesser as compared to the surface of the earth. So that is why in Murray and Nassau-Gully, the atmospheric pressure is lesser than that in Islamabad or Lahore, because uh, the elevation is high in Murray and Nassau-Gully. So any question regarding atmospheric pressure? That is actually the atmospheric pressure. The pressure of the atmosphere is atmospheric pressure. Now we check the definition of gauge um, and negative and absolute pressure. So how gauge pressure is defined? Just check this figure. This is the x-axis corresponds to the absolute zero pressure. Okay. This line corresponds to absolute zero, which is we call this line as absolute zero, and above this line there would be the positive absolute pressure. So any pressure whose reference is absolute zero line will be called as absolute pressure. Okay, and so we measure atmospheric pressure in terms of with reference to the absolute zero. Okay, so we measure actually we would be having the absolute value of pressure of atmosphere. Okay, uh, all the time in any time. So atmospheric pressure is measured with reference. So if this so if I say that there is the atmospheric pressure is say 14 psi. Okay, so this is atmospheric pressure, and I'll put small a with ps with its unit. Why the small a? Because it is absolute pressure. This atmospheric pressure is actually absolute, and its reference is from absolute zero. So usually this A is written with the absolute pressures value. Okay, so to just show that it is absolute. So from here to here it is atmospheric. Now gauge pressure, and if there is some cylinder and you are measuring the pressure of that cylinder through the gauge, and it gives some value. Uh, please give me 1 minute, I'm just coming back. Okay, if gauge measures the pressure as 20 psi, okay, so that 20 psi is with the reference line for this 20 psi is atmospheric pressure line. Okay, if this is atmospheric pressure and the gauge will measure above this atmospheric pressure. Okay, so if I ask you to let me know about the absolute pressure of which you have measured, which is if the gauge pressure is 20 psi, let me know about absolute pressure. Then you need to add this atmospheric pressure to it so that you can get atmospheric absolute pressure. So P absolute in this case would be equal to 20 plus 14, okay, and that is 34 psi. So this is absolute pressure. Now I'll be writing small a with this pressure to show that it is absolute pressure. So this is what the difference between absolute and gauge pressure is. So sometimes there you may observe the negative pressure. Negative pressure means if the gauge is giving negative pressure, so it means that the pressure is less than the atmospheric. Okay, negative pressure is the pressure which is less than the atmospheric pressure. So if the negative pressure, if this value is, this is negative pressure and this value is 10 psi, sorry, not 10, 5 psi, okay, this value is 5 psi. So what about the absolute pressure for this case? If this value is 5 psi, which is negative vacuum gauge is, the reading of vacuum gauge is 5 psi. So it is actually minus 5 psi gauge pressure. And what about absolute pressure? So absolute pressure would be from here to here. Okay. So it would be 14 minus 5 equal to 9 psi A. Okay. So this is what I wanted to tell you. The definitions are written here. You can check the definition by yourself. So again, the atmospheric pressure is measured with the help of barometer. There are different kinds of barometer. One is liquid barometer. The other is the digital analyte barometer. Tell you about the liquid barometer. The configuration of liquid barometer is shown in this figure. It consists of a transparent tube which is open from one end only. The tube is filled with liquid and is inserted in a jar also containing the same liquid. The liquid initially drops in the tube due to gravity but stabilizes at certain level under the action of atmospheric forces. The atmospheric pressure is then measured as the height of liquid at which it stabilizes. So when this tube is inserted in a liquid, in the same liquid, and this tube has also is also containing liquid, then what will happen that the liquid will be moving inside the tube, okay, until or unless it gets stationary. The liquid in the tube gets stationary. So when there is a stable condition of the height of the fluid in the tube, then you get the reading. Okay, so three forces would be acting on a fluid in the tube. What are those three forces? One is the pressure from the bottom, and that pressure is actually the atmospheric pressure. Okay, so here if this surface of the liquid is exposed to atmosphere. So it is subjected to atmospheric pressure. So if this surface is exposed to atmosphere, and some pressure is there, which is atmospheric pressure, then at same level, this atmospheric pressure would be in opposite direction in this tube. Okay, so here there is atmospheric pressure, then at the same depth, the fluid is subjected to the same pressure. Okay, but the direction of that pressure would be opposite. If here it is atmospheric pressure, then because the depth is same, so if the depth is same, the pressure would be the same. As you have already done the Pascal's law, this is actually the Pascal's law. At the same depth, the pressure from all the direction would be constant. We have proved this law in the previous lecture. So if here is atmospheric pressure, then here would also be the atmospheric pressure in the upward direction. Okay. So due to this atmospheric pressure, force is created, and so force due to this atmospheric pressure is one of the forces. The other force is the force due to the vapors, if some vapors are produced above this fluid in the tube. Okay, so there is a force due to vapor pressure here, and the direction of that force would be downward. And one force would be due to the weight of fluid in the tube. Okay, and the direction of that force would also be downward. So, since this fluid in the tube is stationary, so you can apply the laws of equilibrium. And to apply the laws of equilibrium, the summation of Fy is equal to 0. Putting all the parameters in this summation, like all the forces in this summation, which are acting along one axis, and that axis is, we call this vertical axis as y-axis. Okay, so this the force due to it. This is, you can say, atmospheric force. P atmospheric, which is atmospheric pressure multiplied by area of cross section of this tube. Okay, minus sign indicates that weight is downward, minus W minus V vapor, which is vapor pressure multiplied by area of cross section of the tube, is equal to 0. So on simplifying, you'll get this expression. This is the final expression, and through which you can calculate the atmospheric pressure. So usually in this type of barometer, the liquid which is used is non-volatile liquid. The vapor pressure for non-volatile liquid is very less and can be negligible. So, and only when the vapor pressure is negligible, then atmospheric pressure is depending upon only the specific weight of the fluid and the depth of the rise of fluid inside the tube. So any questions, please let me know. Check this slide. Generally, mercury is preferred liquid because its vapor pressure is minimum. Moreover, its specific gravity is very high, so that size of barometer required is small. However, for other liquids, vapor pressure must be considered an estimation. The barometer using mercury is called mercury barometer, and while using water is called water barometer. Size of barometer tube should be more than ½ inch to avoid capillarity. Now there is another term which is called as capillarity. Capillarity is actually significant when the size of the tube is less than 1/2 inches. Capillarity error. You might have done some experiments in your FSC or method that in which um, uh, uh, you just consider the capillarity error also while reading while measuring any length or height in the fluid using the tubes. So that is actually called as capillarity error. When the tube size is less than half inch, so you should consider the capillarity. So usually in this type of liquid barometer or in liquid barometer, the tube size is taken as greater than half inch to avoid the capillarity error. Okay, so capillarity is actually the property of fluid uh, in which the fluid rise or falls, rises or falls in a small direction. Okay. Let's check some of the applications. Neglecting the pressure on the surface and the compressibility of water. What is the pressure in kPa at the depth of the instrument 4600 meters below the surface of the ocean? The specific weight of ocean water under ordinary conditions is given. So this is very simple. Just you need to apply this P is equal to gamma H equation. Okay. An open tank contains water 1.5 meter deep, covered with 2 meter thick layer of oil. What is the pressure at the bottom of the tank in terms of water column? So there are two things you should be considering. One is they have asked you to find out the pressure at the bottom of the tank. Then another thing that you have to give the value in terms of water column. Okay. So how would you get the total pressure at the bottom of this tank? This tank uh, has water as well as oil in it. So 1.4 meter depth of water and 2 meter depth of oil in it. So okay. So how would you get the pressures? So the pressure due to oil here. What about pressure here? Pressure due to the depth of oil, it would be gamma of oil multiplied by depth of oil, which is H now. Okay, and you need to calculate gamma of oil if you know the specific gravity. So gamma oil can be calculated using the specific gravity of the oil. It is specific gravity is specific gravity is S, and gamma of water is also given. It is 9810 Newton per meter cube at standard temperature. Okay, so since you need the standard value of a standard substance, okay, so that's why we consider that the standard value of specific weight of water is 9810 STP. STP is standard temperature and pressure. So gamma of oil would be 0.855 multiplied by gamma of water 9810, and you'll get that in Newton per meter cube. What is the value? Please let me know. It is okay, and then putting the value of gamma of oil in this equation. and you get the pressure of oil here at the interface. Okay, so pressure of oil will be 16775 Newton per meter square. Okay, again you'll be calculating the pressure of due to water depth. So the gamma of water multiplied by HW, and we'll get some value. 9810 multiplied by HW is 1.4. You get the value of pressure of water. Total pressure at the bottom can be calculated. Total pressure would be pressure of oil plus pressure due to water depth, and you will get some value. Value if finally calculate it and let me know. The total pressure at the bottom of the tank. Please let me know. Am I audible?
Yes, ma'am.
Okay, can you calculate the value?
30509.1.
30509.4 Newton per meter square. Okay. You just verify this value later on, but let me tell you how would you get the value, this value in terms of water column. How would you get it? This is the total pressure at the bottom. So you need to find out pressure head in terms of water column. Pressure head in terms of water column would be calculated like this, gamma W. Okay, so you would be dividing this total pressure with specific weight of water to get the pressure head in terms of water column. So this is how you get the pressure head in terms of different, in terms of depth of column of different liquids. So if I ask you to determine the pressure head, just write the value in terms of pressure head in, of oil column, then what would you do? You will be dividing the total pressure with the specific weight of the oil to get the column of oil. Okay, to get the height of column of oil, pressure head in terms of oil column. So this is how you get the values in pressure head. So any question, please let me know. Okay, this is another similar type of question, and I expect that you'll do it yourself. Again, the same type of question in which application of this equation, which is P is equal to gamma H, has been shown. Okay, this is the application of the equation which we derive for the barometer, liquid barometer. Let's check it. If the atmospheric pressure is equivalent to 33.4 feet of water, what must be the reading on a barometer containing a liquid if the vapor pressure of the liquid at the temperature of observation is 2.09 psi? Now if you need to find out the reading of this barometer. So they have provided you with the atmospheric pressure, okay, which is 33.4 feet. Okay, this is the atmospheric pressure. So first, this atmospheric pressure is in terms of pressure head of water. If you are providing the value of pressure head, then you must specify that pressure head of which liquid you are specifying, okay, or giving. So they have specified that pressure head of water is 33.4. So to convert this fluid into the pressure intensity unit, one term is called as pressure head and the other term is called as pressure intensity. And the relationship between the two would be the same which we just have discussed. Like if P is equal to gamma into H. So P is the pressure intensity and H is the pressure head. Okay. So they have provided us with this H value. Okay, so if H is provided to you and you need to convert that H into pressure intensity, then what would you do? You would have to multiply. Sorry, yes, you would have to multiply the pressure head with gamma of the liquid. Here, water, the pressure head is for water. Then you would have to multiply this value with gamma of water to get the pressure intensity. So this is the atmospheric pressure in terms of PSIA. So they have done it like this. Gamma of water uh, in British gravitational system is 62.4 multiplied by, since H is given, H is 33.4. Okay, now the value would be in pound per, the value would be in pound per feet cube. Okay, but here they have they calculated in PSI. Yes, you can convert it to PSI by multiplying it with what, 12 multiplied by 12. Sorry, not multiplying, divide by. Okay, divide by 12 cubed. Then you'll get the value in PSI. Sorry, 12 square. I'm sorry. Okay, so that is how you can convert a pound per square foot to pound per square inch. So this is how they get this 14.47 PSIA value. Vapor pressure is given, which is in PSIA. So you need to be consistent in units. Since vapor pressure is in PSIA, so you will convert atmospheric pressure to PSI. Now, according to laws of equilibrium, you apply this summation F is equal to 0, putting all the forces in this summation, and you already know that how many forces are involved in this summation. Atmospheric pressure force, weight of the fluid in the tube, then force due to vapor pressure, okay, should be equal to 0. And then you can get the expression for this height of liquid in the tube, which is to find out. This is unknown in the question. All other parameters would be known to you except this H value. So you can calculate H through this formula. Okay, any question please? Calculate it and let me know in the next class. Okay, so you just need to use the law of equilibrium, getting the expression, though this expression we just have derived for the liquid barometer, but you can easily derive it again and again if you want. Okay, H is the unknown and which can be determined using detect pressure. The following devices are used for pressure measurement: piezometer, manometer, mechanical pressure transducer, electrical pressure transducer. So let's discuss about piezometer. It is, so you can see that we need to measure the pressure in the laboratory using the piezometers, or we need to measure the pressures at uh, uh, any system of pipes which has been installed anywhere for any reason. So it, we use piezometer for that purpose, and we can also for that purpose. Mechanical and electrical transducers are also used for that purpose. The pressure, the parameter which is called pressure, is very important in determining many other factors in the flow dynamics of the fluid in either in a pipeline or in an open channel. So that's why we need to use different equipments to measure that pressure. So as far as piezometer is concerned, it is very simple equipment which can be installed in a pipeline. It consists of a transparent tube open from the other end. The diameter of the tube should be greater than ½ inch to avoid capillarity action. Piezometers may be connected to sides or bottom of the pipe to avoid eddies that are produced in the top region. Limitation: it must only be used for liquids. It should not be used for high pressure. It cannot measure vacuum pressure. So these are its limitations. You can use this piezometer for the measurement of pressure of liquids only. Okay, if a liquid is flowing in a pipeline, then you can measure measure the pressure with the help of piezometer. And if the pressure is very high in this pipeline, say for example, pressure is very high here, so this you need to install the very high tube in order to measure that high pressure. So you cannot measure high pressure with the help of piezometer because it is cumbersome to use that, or installation is difficult. Okay, so for that purpose, to measure high pressure, there are some other equipments you can install in the pipeline or any system of flowing fluids. Okay, so this figure is the cross section, and this figure is the longitudinal section of the pipe. And the depth of the fluid in the piezometer would give you directly the pressure head value. Okay, at that point. Okay. Okay, there is another equipment which you can use it for the high pressure as well as for the negative pressure, and that equipment is called as manometer. Manometer, you can see the figure is has been shown in this slide. Is a U-shaped tube or N-shaped tube, part of which is filled with manometric fluid. One end of the tube is connected with the pipeline. This is the cross section of the pipeline, and the other end of the tube is free, okay, open. Due to pressure, level of manometric fluid rises on one side. Now, due to the liquid pressure, as the pressure increases, or as the liquid progresses or flows in the pipeline, and it passes through this section, which is A section, where manometer is installed, the liquid will go in the tube, in the manometric tube, and it will push this manometric fluid upward. First in this tube downward, and then here it will push it in upward direction. So using the change in the height of fluid in the two tubes you can calculate the uh, pressure at point A. Okay, the difference in levels is measured to estimate the pressure. So this difference is important. So you will have to write the manometric equation to find out the pressure head. Yes, in that manometric equation, you'll be using this difference of level of fluid in the two tubes of the manometer. So let's check how would you write the equation of manometer to get the pressure at point A in the pipeline. So let's first discuss the properties of manometric fluid. Manometric fluid should not be soluble with the fluid flowing in the pipeline whose pressure is required to be determined. Lighter fluid should be used if more precision is required. So let's check how would you get the pressure at point A when manometer is attached with it, and due to that pressure at point A, the fluid will move downward in the tube, in one tube, and it will rise in the other tube. So we need to decide about the sign convention. Though the same law is applied here also, which is change in pressure. The law which is applied in writing the equation is the same. It is change in pressure with respect to change in Zx is equal to minus gamma. The same law is applied to write the equation. And according to this law, we decide our sign convention. Sign convention is when you go in upward direction, like you have to measure the pressures in the tube. Okay, so when I'm measuring the pressure, like from here to here, the pressure of liquid from here to here, then as I'm going downward, then I'll be taking positive sign, and when I'll be going upward in this tube, I'll be taking negative sign, like from the pressure from here to here. Okay, the same principle, just remember that the same principle is applied here. Okay, so like if I'm going from here to here, P1 would be here and P2 would be here. P2 minus P1 similar, and Z2 minus over Z2 minus Z1 is equal to minus gamma. The same principle is applied in this case. So the sign convention is according to that principle which we have derived in the previous class. Okay, and sign convention is uh, negative pressure would be in upward direction and positive pressure would be in downward direction. So keeping this sign convention in mind, you can find out the equation for pressure at A. Let's write. You can start writing the pressure equation from any direction. Either you can start from the pipe or you can start from the open end. Okay, so we must start it from one side. Okay, to write the equation, we will be adding the pressures uh, or subtracting the pressure according to the sign convention, and reach to the final reach to the other end. Okay, so let's start from this end. Okay, so PA, which is the pressure which you need to find out. Pressure is applied in this pipeline, and then this it the what would be the pressure over here? It is if the depth is Z from this point. So you need to, if you are going downward in the tube, you need to add the pressure. So plus Z multiplied by gamma of the fluid. The specific weight of the fluid is gamma F. Z multiplied by gamma F. So since we are going downward, so we are adding the adding this pressure. Okay, again I'm going downward, and now I need pressure over here. Okay, so if this distance is say A, okay, So what about the pressure over here? Again, plus A multiplied by gamma of manometric fluid, gamma m. Okay, and then again, now I'm going upward up till this point. From here to here, the length is A. So now, since I'm going now upward, so I'll be putting negative sign. A multiplied by gamma m. Okay, so it means that the liquid in the tube, or the same, if the liquid is same in the tube and is in U-shaped part, you can just cancel the pressures uh, obtained from this depth of U. Okay, so this would be cancelled out. Then I'm again going upward. I have the distance y. Now my destination is this, the surface of this manometric fluid. From here to here, I'm going upward. It will be minus y. Y is the distance multiplied by gamma of m. Okay, and then what about atmospheric pressure? Is equal to atmospheric pressure. Okay. So the pressure you'll be getting through this equation would be absolute pressure, because you are considering atmospheric pressure on the other end. Okay, so this is atmospheric pressure and it is downward direction towards the fluid. So that is why you use this. If you are writing this atmospheric pressure on the other side, then you will be taking negative sign, since you are going upward in the tube. So this is how you write the manometric equation. So in this manometric equation, this parameter would get cancelled, and you are left with this equation: PA absolute plus Z gamma F minus Y gamma M is equal to P atmospheric. Okay, so this is how you measure the pressure head using the manometer. This is another example. This is called pressure manometer. And as the name implies, through differential manometer, you'd be able to find out the difference between the two pressures. Okay, so if the differential manometer is attached with the two pipelines, then how would you get the value of the difference of the pressure? Again, you'll have to use the equation of manometer to find out the difference. So you can start the equation from any of the tubes. You can, if we start here, then this would be the manometric equation. So let's start the equation from, you can understand, using the same principles. So PA, okay, and then this step ZA, and we are going downward in the tube. So plus ZA into which fluid is that? It is gamma A. Okay, and then again this U part would be cancelled. The depths are equals and the fluid is same, so that the pressures are cancelled. And then we are left with from here to here. Okay, and we are going upward. So it would be, I should be writing negative sign, Y multiplied by gamma of manometric fluid. Okay, again I'm going upward, and the distance from here to here is ZB. So minus ZB into gamma of B, okay, is equal to PB. So this is how you write the equation for differential manometer. So the main, if you are able to write the correct equation for the manometer, uh, you can easily find out correct pressure. If the equation is wrong, then the answer would also be wrong. So you just practice to write the correct equation of manometer to find out the pressures at the pressures in the fluid system. And fluid system can be the fluid flowing in the pipeline, fluid flowing in any conduit, or fluid flowing in an open channel. So this is how you can find out the pressure. So again, this manometer can be used when the two vessels are at different levels. And the principle is same to write the manometric equation. The equations have been written here. This is inverted manometer, differential manometer. So there can be different cases and different configuration of manometers which you can use to measure the pressure in a system. Advantages and limitations. Advantages: easy to fabricate, less expensive, good accuracy, high sensitivity, require little maintenance, not affected by vibration, especially suitable for low pressure and low differential pressure, easy to change sensitivity by changing manometric fluid. And limitations: usually bulky and large in size, being fragile, get broken easily. Reading of manometer can get affected by temperature, altitude, and gravity. Capillary action is created due to surface action. Yes, that capillary action can take place when the tube size is less than ½ inch. Meniscus has to be measured accurately for better accuracy. So these were advantages and limitations for the user. Let's check one application. Question. The figure, just check the figure. In figure, originally the manometer reading is given, which is 10.16. Okay, the manometer reading is that length, which is the difference of the length of manometric fluid in the two tubes of manometer. So this is actually, this 10.16 is actually the manometric reading. This is manometric reading. When h is 1.524, this length is also given. This is h. Atmospheric pressure is given, which is 101.3 kilonewton per meter square. If the absolute pressure at A is doubled, what will be the manometer reading? So let me know how would you do that. So first you need to find out the absolute pressure at the present condition, and then you'll be finding out the reading of the manometer when that absolute pressure is doubled. So first determine the existing pressure. To determine the pressure at point A, you need to write the manometric equation. and this is the manometric equation. Pressure at A plus this depth multiplied by the gamma of water, okay, and then this u part is cancelled, okay, and from here to here depth is given 10.16. So 10.16 was in centimeter, convert it into meter, dividing by 100, you'll get in meters. 0.106 multiplied by gamma m is the pressure due to this height. Okay, negative sign is indicate that we are going upward in the tube. According to our sign convention, you have to put negative sign, and then is equal to P atmospheric. Here P atmospheric. Okay, so this was the equation, and you'll get the ASCII pressure using this equation. All the other parameters are known to you. Okay, then you need to find out, they have asked you to find out the manometric reading when this ASCII pressure which you have calculated in the first case is doubled. So you need to write down the equation for that scenario also. So when the pressure is doubled, so what will happen? If there is more pressure, the liquid would be pushed further in the tube downward. So if we say that liquid is pushed downward x distance downward, okay, this is x. So if x distance is pushed downward in one tube, then the same dimension, with the same dimension, it would be pulled up in the other tube. Okay, so it means that now the liquid will be from here up till here. Okay, if the pressure is doubled, then here it is the same fluid. This fluid with greater pressure, it will be pushing the manometric fluid further downward using of x dimension. Okay, and if x dimension is pulled downward, is pushed downward, then in the other tube, the x, the same dimension would be pulled upward. Okay. Now using this configuration, you can write the equation. So here, how can you write the equation? You need to measure this difference of the what is unknown. Unknown in this question is the manometric reading when the pressure is doubled. And manometric reading, as I have already told you, is the distance, the difference of the length of the fluid, manometric fluid, between the two tubes of the manometer. So this is actually unknown in the question. Okay, so we'll check this dimension, but first we need to write the manometric equation. If we know x, then you'll know this dimension also. Since from here to here, here to here, it is x. Okay, and again, this increased dimension of the fluid in the other tube is also x. So how would you write the equation now? Let's write it. Now starting from this end, PA, okay, and we are going downward at the tube. H depth is known to you, plus H multiplied by gamma of water. Then again we have to go downward with x distance. X is also the same fluid, water. So plus x into gamma of water. Okay, and then this u part would be cancelled, and now we are moving upward. Okay, from here to here, it is x distance, so minus x into gamma of manometric fluid, which is manometric fluid here is mercury. And then again this distance, first we know this distance from here to here, which is 10.16 centimeter. So we'll be writing accordingly. Minus 0.1016 gamma of Hg, isn't it? And then again this dimension is known to you, which is x. It will be minus x into gamma of Hg is equal to P atmospheric. Okay, so you are given with this value P atmospheric. This is 2 PA absolute. This is this pressure is for the first scenario. Okay, 2 PA absolute. You have this value of PA absolute. So you have all the other parameters with you except this x. Okay, so you need first you calculate this x value. After getting this x, you can use this x to find out the reading of the manometer. Okay, reading of the manometer would be of manometer is equal to, it is x plus 0.1016 plus x. So this is actually reading of manometer, which is 2x plus 0.106. Okay, so this is how you can apply the equation of manometer to find out the value of pressure. Any question, please let me know. Any question? There are some other questions like the same. You just need to write the correct equation for the manometer and get the value of pressure. I expect that you will be doing these questions in the presentation. One is full manometer and manometer, this and the to the differential manometer. There is no other rule than the writing the correct equation to have the correct answer. Okay. Any question? Okay, that's all for today. Thank you so much. If you would have any question regarding today's lecture, you can always send me an email or you can send me a message. I'll try to answer. Let me download your attendance, then you are free to leave.